So section 4.8, talking about imaginary numbers, complex numbers. We looked at how to simplify a square root of a negative number using I and breaking down a square root. We looked at adding complex numbers where we add the real part, add the imaginary part, and come up with one imaginary or complex number. Today we're going to talk about multiplying complex numbers and then dividing complex numbers. And then we'll maybe solve a couple equations. So multiplying complex numbers, we'll start with an example. So multiplying complex numbers, I put a number of different situations here. One where we just have the imaginary portions multiplied together. One where we have an imaginary portion times a complex number with both parts. One where we, and then two where we have both the real and imaginary parts together multiplied, okay? So what is each product? What is 7i times 3i? Guess? 21i squared. Now, what does I squared equal? So I equals the square root of -1. So I squared is going to equal the square root of -1 squared, which is just -1. So I squared equals -1. So -1 times 21, I get -21 for my final answer. Part B, we would distribute. So 3i times -5 is -15i. 3i times 2i. 3 times 2 is 6. I times I is I squared. I squared equals -1. And we always put the real part first. So I squared is -1. -1 times 6 would be -6. So I would put -6 first. And then minus 15i. In C, we're going to distribute by foiling, basically. First with first. So 2 times 4 is just 8. Outers. 2 times 5i is 10i. Inners. -3i times 4 is -12i. And last with last, I have -3 times +5, which is -15, and I squared. I squared equals -1. So I have 8. -15 times -1 is +15. So really I have 8 plus 15. Then I have a 10i. Subtract 12i. 10 subtract 12 is -2. So 23 minus 2i is my answer. Now the last one. We're going to do it the same way as we did C. So first with first, 3 times 3 gives us 9. 3 times -i is going to give us minus 3i. Inners, 3, or I times 3 is going to give us positive 3i. And then last with last, I have a positive I times a negative I, which is going to be a negative I squared. So again, I squared is negative 1. So I have a subtract a negative 1, which is going to be plus positive 1. So 9 plus 1 is 10. And then I have minus 3i and I have plus 3i, which are going to drop out to 0. So you just end up with a real number 10. When we multiply two numbers like this, where they are the same values, but the middle sign, our middle signs are opposite, so we have a 3 and we have an I. One's plus, one's minus. You are always going to end up with a real number when you multiply them. The imaginary parts will go away. When you look at the division of complex numbers, if you look at the fraction in part A, we have 9 plus 12i divided by 3i. Okay. Now, you should recognize that 9 and 12 are both divisible by 3. So we could and should be able to simplify that. Okay. The other piece of this is that a fraction is not considered simplified if it has a square root in the denominator. Okay, we cannot leave a square root in the denominator of a fraction. So if there's an I here, an I really is a square root. So we cannot leave an I in the denominator of a fraction. So what we are going to do is we're going to multiply the top and bottom by something so that we can get rid of the i's in the denominator. Now, if you just have a single I in the denominator like A, we can just multiply by I. Which is going to give me, distributing, 9i plus 12i squared divided by 3i squared. And the reason that helps me is because I squared equals negative 1. So I have 9i minus 12 divided by negative 3. So 9i, 12 times negative 1 gives me negative 12 divided by negative 3. Now, 9 is divisible by negative 3, as is negative 12. So 9 divided by negative 3 gives me negative 3i. Negative 12 divided by negative 3 gives me plus 4. But I should really write it as 4 subtract 3i. Real part, then imaginary part. So if you have a division problem where you just have a number and an I on the bottom, or just an I on the bottom, multiply by I on top and bottom and simplify. But what happens if we have a problem like B? We are dividing by something like 1 minus 4i. In this case, you are going to multiply by the conjugate. So the denominator is 1 minus 4i. You are going to multiply the top and the bottom by 1 plus 4i.